On the back side of 2.7, which this is the last part of unit or topic 2 as well, we are now solving inequalities. So on the front side yesterday, if you recall, I think it's still up here, yeah, we solved systems of equations where it was a linear and quadratic, so looking for where does my line and my parabola intersect. Then we used substitution, which wasn't as bad as the original substitution, right? The substitution was pretty easily when you're setting an equation equal to an equation. And now we're going to look at solving a system of inequalities. I gave you the hint on there using shading. So we're not just looking for where the two lines intersect, we're looking for where the shading overlaps. So let's pick one and start with it. This first one here, y is, what symbol is that?
Greater than.
Oh. You guys had a 50-50 shot.
Greater
than.
Oh, yes.
Okay.
Sir.
And guys, it starts with the bigger end, right? I don't know. Do you need your little... You need to write yourself a note here. Okay. That one's going to be greater. The one that starts with the small end is your less than. You need that, put it up there, right? So, when we go to graph y greater than x squared minus 4, I want you to just think about y equals x squared minus 4. We'll worry about the greater than, what that means here in a moment. But the graph, y equals x squared minus 4. Thoughts there?
Are we going to play the...
What do you mean?
It's like yesterday.
Like yesterday? Well,
Put it in the form.
okay. So now, here's the question. Difference between these quadratics today, right? Because x squared means it's going to be a parabola. Difference between this one and the ones we saw at the beginning of class yesterday. The ones we saw at the beginning of class yesterday were in that ax squared plus bx plus c form. And we had to use axis of symmetry and vertex. We had to use that x equals negative b over 2a, yes? Okay. We could do that again, or we could make life easier here. This is x squared, which indicates it's a parabola. What's the minus 4 do?
Make it a negative, it makes it go down.
Makes it go down 4? Okay. Because it's just an x squared and a number added or subtracted. In other words, because there's no like x term. We can just think about this as this is going to be a parabola that moves down 4. Okay, so the x squared tells me it's a parabola. The minus 4 tells me it moves down 4. What's the basic shape, or what ordered pairs do we use for a parabola? We did talk about this yesterday.
0, 0, 1, 1, 2, 4.
Yeah, if this is a basic 1x squared, which it is, when you go to graph this parabola, get your vertex, and then from the vertex go over 1 up 1, over 2 up 4. Okay? Okay, now, the other question is going to be, questions. Well, okay, let's go ahead and put our points here. Parabola moves down 4. So what's the first thing we do?
Put down 4.
Yeah, take your vertex and move down 4. What's the shape of this graph then?
A U.
It's a U. So from this vertex, because it was a 1x squared, I can go over 1 up 1 and over 2 up 4. Now, this is where I'm going to pause. I'm not going to connect my dots yet. Okay, because when we do an inequality, we have questions about how do we connect those dots. Okay. Do you guys remember? How do I connect? Am I connecting them with a solid line or a dashed or dotted line?
Oh, it's gonna be a dotted line.
Why?
Because there's no or equal to.
Okay, does that sound familiar? He's on it. Okay. Was I writing dotted or dashed? I don't remember. I don't know. Because it is not equal to, we're going to use a dashed line. Okay, which a little bit more interesting to do on a parabola. Something like that. And are we going to shade above or below?
Above.
Why above?
It's a greater than.
Greater than always says shade above. Does this sound familiar? Now, where is above this parabola?
So right.
No?
Where is it? Where?
Think up or down.
Up.
So up, what is above where this graph is? Or above where we drew the line? It's going to end up being the stuff that is inside of it. Yep. Okay. It's going to end up being the stuff above. Because when we talk about above, it has to be above the line you drew. Okay, so above that line is going to be in the parabola. What would have been below?
Everything else.
Everything else. It would have ended up, the way this parabola is faced, everything below would have been everything outside the parabola. Okay? Okay, now we're not done. What else do we have to do?
The y less than 2.
Okay. We also have to graph y. Notice he said less than 2. So if it's y less than 2, think about how do we graph y equals 2?
Is it just a flat line?
It is just a flat line. You could think of it being a y-intercept of 2 and a slope of 0. You could think about it that way. Y-intercept of 2, slope of 0, but it is a horizontal line. So I'm going to go up to a y-intercept of 2, and it's going to be a horizontal line. Now, again, before you connect those points, how are we connecting those points? Are we going to do a dashed line or a solid line?
Dash.
Dash, because again, it is not equal to. Okay? Remember, dash lines happen with less than or greater than. And then, are we going to shade above or below?
Below.
And why would we shade below?
Less than.
Because anytime it is a less than, you shade below. Does that sound familiar? Now, where's below on this one?
Just below it.
Below it, right? Fairly obvious. Definitely looks better on your paper than my BenQ. Now, I'm not going to quite give you full credit here. What I need to understand that you understand. Where's my answer?
Oh, it's gonna be where they both overlap.
Yeah, where's my shading overlap?
Like right there.
Yeah.
Like right in the middle.
That almost triangle-ish area in the middle, okay, where my purple and my green overlap, which is inside. So you don't even have to use, I know you guys like your colors, I'm not against the colors, I change colors too, okay, but you don't even have to use colors. Just kind of darken it a little bit. Just something so that I can tell you recognize, oh, that's where the overlap. Okay? Okay, questions there? Okay. Well, part B. We're going to start off with the x squared plus 1. What sign is this? It's greater than or equal to, technically. Now, when we go to graph it, I personally am just going to say, okay, how do I graph y equals x squared plus 1?
You go up 1 on the y-axis.
Okay, we go up 1. And again, this is still x squared is still a parabola, yes? So this tells me it's going to be a parabola. Plus 1 tells me I'm going to go up 1. It's still a 1x squared, so we can still use the basic idea of 0, 0, 1, 1, and 2, 4. Okay, so I'm going to take my vertex and go up 1. From there, complete your parabola shape. My parabola shape, over 1, up 1 in both directions, and over 2, up 4 in both directions. Dashed or solid line?
Solid.
Why is this one solid?
It's equal to.
Okay. Anytime you have that equal to, whether it be less than or equal to or greater than or equal to, it's a solid line. So normal everyday parabola looks something like that. Where am I going to shade?
Above.
Okay. It is a greater than sign again, isn't it? And anytime it's any type of greater than sign, we shade above. What does above look like in the form of a right side up parabola?
Where do you like to use it?
Yeah, it's going to be inside of it. Now, if your parabola was upside down, it'd be a different story. It'd have to be outside of it, okay? And y greater than or equal to negative x plus 3. Again, if it helps, I'm thinking I must have brushed up against, I have no idea. Hopefully I just brushed up against the screen. Okay, y equals negative x plus 3. What do we know?
Oh, it's just a regular slope.
Okay. Regular line. It's in that mx plus b form that we talked about yesterday. So we know our y-intercept is 3. And we have a slope of what?
Negative 1 over 1.
Yeah, invisible negative 1, which as a fraction is negative 1 over 1. And in your brain, you're saying, oh, slope, that means I'm going to do what? Rise over run. Okay. Start off with the y-intercept of 3. Right there in the middle of that shaded purple. Slope of negative 1. We're going to do what?
Down 1, right 1.
Down 1, right 1. Down 1, right 1. You can also reverse it and go up 1, left 1. There are inequalities, so ask yourself about the type of line.
Solid.
Okay, this is an equal to again. So we're going to use a solid. And above or below?
Above.
It is greater than, isn't it? Anytime it's any type of greater than, we're going to go above. Above it, go with the angle here. Above it means over there. This is all great and grand, but I don't feel like you can tell me where your final answer is until you show me.
Where they overlap.
Okay, where they overlap? It's inside the parabola, isn't it? But it's above the green line. Okay. Now, reminders. Savas. You just pick the final shading, don't you? Okay, so if you feel something might be helpful, sketch it on your, on a piece of paper or something, maybe if you need to. But, kind of, visualize, okay, above, where's that overlapping? Okay, questions there? We know we do the shading, and we know that we do the solid and dashed lines when we start seeing the inequality symbols. Okay, those are your clues. When you see less than, greater than, think, oh, you have to do two extra things. I have to do a dashed or solid line, and I'm going to have to shade. Okay? Okay. One more topic then. And this bottom section asks us to use a system of equations to solve a single equation here. Okay? Now, could we use techniques we used yesterday? Okay? Where we get this equal to 0 and try and solve. We could, but I'm going to tell you up front, these aren't the type that are going to factor. These are the type that would have to go into quadratic formula. We can make these equations equal to 0 and put them in quadratic formula. Okay? However, if you have graphing technology available, which we do, then we have another option. So they say to use the graphing calculator. Okay? I'm going to have you guys use Desmos. But the idea here is solve an equation by writing a linear quadratic system and solve using the intersection feature of a graphing calculator. We talk about this, okay? A linear quadratic system. Basically, your left is going to be one equation. So we're going to graph y equals x squared plus 9x minus 5. That's your quadratic part. And then, what else are we going to do? We're going to graph y equals 4 minus 3x. And then, of course, we're going to look for the intersection points. So, grab the iPads out, and let's work on this. I did not think... There we go. Oh my gosh. You guys are going to have this way done before I ever get there because I forgot to pull it up ahead of time, but that's good. Guys, remember when you get to Desmos, you can go open graphing calculator, you can go to math tools, resources, there's a couple different places you can look. Math tools, graphing calculator. Or it probably just comes up there already, doesn't it? Okay, remember you just have to type it in. Y equals, and you don't even have to put the y equals, but I like to. X squared, remember x, then that a squared thing does it for you. Plus 9x minus 5. Okay, I can enter down to the next one. I'm doing y equals 4 minus 3x. Now, Let me get this keyboard out of the way. This just is how it came up. It's kind of zoomed in, isn't it? Zoom it out. Here's the deal. You guys know you can adjust, yes? I can't even see my full graphs right now. So I definitely need to recenter my screen a little bit, get to where I can see the whole thing, yes? There's a little bit better view for us, isn't it? Okay. Adjust yours however you need to, because that's something I've sometimes had to help with. Now, with this, what do I need to know? Where they intersect, right? Remember in Desmos, it's a piece of cake. You can just tap the point, yes? So I have this one that's at negative 12.708 and 42.125. It looks like I have my answers as 2 decimal places when I get over to the next screen. And then be careful, tap the correct one here. 0.708 and 1.875. Desmos cooperating with you? Okay, I'm going to go back to my notes here. And I'm just going to kind of draw a quick picture. Just a second, I'll get you. Okay, we kind of basically said we need our 2 points, yes? We need to know those 2 points. Now, those 2 points were the points we looked at on the other screen, 0.708 and 1.875, and negative 12.708 and negative 12.71. Real quick question to finish this off. It said solve this system of equations, yes? In our original system of equations, what did we only have? What's the only variable we had in the original system of equations?
What? Repeat that?
What's the only variable I had in the original system of equations here? X. Do we want the y values? Do we need the y values? No.
It's a 3 on the 12.
Okay, hold on. What is today? The 4th, right?
Alright, chill out, buddy.
I can't help it.
Okay, there you go, sorry. Okay, so first of all, are you saying you don't like this comma I accidentally put in here, Jocelyn?
Well, I wasn't sure if it was an accident or not.
It was. I was trying to be quick and I goofed it up in the process. That's what I get for trying to be quick here. Okay. The point I'm trying to make here, folks, my original problem only had x's, right? So what kind of answers? What are the answers we need? We only need the x's, okay? The y's are just because we separated it into 2 equations. So we're only looking for x. So my x solutions are the 0.708, which I have it as 2 decimal places in my final answer. That might be what Savas does. And the negative 12.708. So negative 12.71. Okay, they're only going to be looking for the x values there. Got it? Okay. One other problem real quick, and then you guys can have a little bit of work time. What are we going to start off doing on B? It's asking us to solve the equation 3x squared minus 7x plus 4 equals 9 minus 2x. We're going to have to graph what?
3x squared minus 7x plus 4.
3x squared minus 7x plus 4. And we're going to have to graph y equals 9 minus 2x. Okay. Head over to Desmos and do just that, right? So y equals 3x squared minus 7x plus 4. There's one of them. And y equals 9 minus 2x. Okay. Now, this is kind of based on how my last graph was. I don't know about you guys, but I personally, I would zoom that in a little bit more. Okay? I would zoom that in a little bit more, just so I can get a good solid view of it. And what are we trying to look for here?
2 points.
Our intersection points. Did I put them up at the same time? Here we go. So the negative 0.703 and 10.407, and the 2.370 and 4.260. Okay? So those are 2 points. I'm going to take them back to my other screen. And again, we had what? We had a parabola intersecting a line. And we are looking for those intersection points, right? Now I'm going to write down my intersection points. 2.37, 4.26, and negative 0.703 and 10.407. What do we really only need to give as our answer, though?
The X.
The x's, okay? There's only x in my original problem, so I only need the x's. So x is equal to the 2.37 and the negative 0.70. Okay? Again, x values only. Okay. If it says use a graphing calculator in homework, that's Desmos. Okay, your graphing calculator is Desmos. So just be aware of that. Unless you have your own graphing calculator and you've learned how to use it, that works too. But
I don't know how to use it.
so. Okay, guys, you have some work time. 2.6 up through 2.6 is due today. And then 2.7 will be due Monday. The next week we'll be looking at some review and getting ready for a chapter test. Okay? And PSAT is next Thursday. No, Wednesday. Excuse me, Wednesday.
Why is it on Wednesday?